Welcome to the Deck Dive, the show where we cut through the noise to get you truly well informed. Today we're tackling a topic that is, well, literally the lifeblood of aviation, and it's absolutely crucial for your ATPL theory exams, aircraft fuel systems and refueling procedures. Our mission here isn't just to, summarize. It's really to uncover the ingenious engineering, the surprising physics, and those rigorous safety protocols that ensure a highly volatile liquid can be safely stored, delivered, and burned, all while keeping thousands of tons of metal airborne and addressing the constant risks. Think of it as answering the question, how do we manage the fiery heart of an aircraft, and what do you, as a future pilot, absolutely need to understand to keep it beating safely?
That's exactly right. Because ultimately, while passing the exam is, the immediate goal, truly grasping these systems is about understanding the fundamental principles that keep, tons of metal safely in the air. Fuel isn't just some commodity, it's the very lifeblood of an aircraft. And every single detail, from its precise chemical composition right down to how it's delivered to the engine, plays an absolutely vital role. This deep dive should hopefully illuminate those critical connections, helping you move beyond just rote memorization to a deep, practical understanding.
Okay, let's unpack this then, the very essence of keeping an aircraft flying. So, let's start right at the foundation. What makes a fuel even suitable for an aircraft? When engineers sit down to design what an ideal aviation fuel would look like, they're not just sketching, they're creating a highly demanding wish list. I hear there are 10 core requirements that are pretty much paramount. Where do we even begin?
Well, first, and vitally important, is ease of flow under all operating conditions. Just imagine an aircraft climbing from a scorching desert runway, maybe 40 degrees C, up to the stratospheric cold of minus 50 C at cruising altitude. And it does that in minutes. The fuel needs to maintain its viscosity and, crucially, not freeze solid. That's a huge challenge right there. Second, it demands complete combustion under all conditions. And this isn't just about maximizing power. Incomplete combustion can lead to carbon deposits that degrade engine performance and can even cause long-term damage.
And efficiency is always key in aviation, isn't it? Which brings us neatly to number 3, a high calorific value. We're talking about packing as much energy as possible into every single kilogram or liter of fuel. Why? Because that directly translates to greater range and endurance for the aircraft without piling on excessive weight, which, as we know, is always a critical factor. Fourth, the fuel must be non-corrosive. This is a really critical point that's sometimes overlooked, I think. It's not just the engine. Think about all the fuel system components, the pipes, the tanks themselves, the pumps, the seals, every single part that comes into contact with the fuel. They all need to be protected from degradation and damage over the entire lifespan of the aircraft.
Absolutely. The integrity of the whole system depends on it. Fifth, we need to make sure that combustion byproducts cause no damage to the engine. You definitely don't want abrasive residues building up or chemicals that accelerate wear on critical internal parts over time. Sixth, and this is perhaps self-evident, is a low fire hazard. Aviation fuels are inherently flammable. That's just their nature. But our goal is always to minimize that risk as much as humanly possible, especially during those vulnerable ground operations like refueling.
Seventh on this pretty demanding list is ease of engine starting. Now, this is vital for quick turnarounds at busy airports, obviously, but also just for basic reliability, particularly in extremely cold weather or remote locations where you need that immediate engine response. Eighth, and this is one that many people might not immediately think of, is lubricity. Fuel isn't just burned for power, it also plays a crucial role in lubricating many components within the fuel system itself, like those intricate high-pressure pumps and the fuel control units that precisely regulate fuel flow. This lubricating property is actually critical for the longevity and reliable operation of these high-precision parts.
Right. And rounding out that comprehensive list, which is sort of implicitly covered by ensuring non-corrosive properties and benign combustion byproducts, is the overarching need for long-term system integrity and reliability. But what's truly fascinating, and this is a critical insight for your studies, is that while engineers strive for this perfect fuel, the reality, the engineering reality, means every aviation fuel is a carefully calibrated.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.